Now a little bit of science for you tonight as we talk about the personal lives of salamanders. The mole salamander only has one sex, female, and in that they have a leg up on other animals.
Are you ready to hear a story about sex that you're not going to believe? Humans have such a perception of reproduction that's human-centric. And when that's challenged, it really throws folks for a loop to think of something that doesn't need its own males, but crosses these species boundaries in order to obtain that reproductive material. What does a world look like with no males, or clonal reproduction? What does that mean from the perspective of these cute little animals? My name is Rob Denton. I'm an assistant professor at the University of Minnesota, Morris. These salamanders are unbelievable. They're an all-female group of salamanders that can steal sperm from males of other species.
My name is Katie Greenwald. I am an associate professor at Eastern Michigan University in Ypsilanti, Michigan. If you think about it, a lineage that's all made up of females can actually grow twice as fast as a lineage that has both males and females. Numbers-wise, that lineage should eventually swamp out, outcompete, and beat a lineage that has evolved to have both males and females.
We sometimes call this the twofold cost of males. It costs to make males, and males take away resources that could be used for females. It's still relatively mysterious why sex evolved and how it's been maintained for so long across so many different species across the tree of life.
The reason that we're so interested in these unisexual Imbestoma salamanders is that they are virtually able to sort of flip-flop between sexual and asexual reproduction. These various options in terms of how these offspring are produced is, as far as we know, completely globally unique, and it makes this system a really excellent one to look at when sexual reproduction is adaptive versus when asexual reproduction is adaptive.
Imagine you are one of these females. You come to a wetland in the spring, and you proceed to find a packet of sperm at that wetland that was laid there by a male of a different species. You require that sperm just to even have eggs, to produce eggs and lay them. You do so, and most of your offspring are clones of mom. They're exactly the same. They have all of the same chromosomes, all of the same genetic material. What makes these animals separate and distinct and interesting is the rate at which those other genomes sneak into the offspring.
Typical sexually reproducing organisms are getting kind of one set of their DNA, set of chromosomes from mom, one set from dad, and so all of us have two sets of chromosomes. The unisexual salamanders, we do sometimes get them with two sets, but it's much more common for them to have 3 or 4 sets, and we sometimes even find them with 5. 5 tends to be about where they max out. Ohio and Indiana are kind of the epicenter of craziness for the complex because there are actually 5 different sexual species that they can reproduce with, that they can breed with the males and then potentially incorporate those males' DNA. It's not only that they have these different potential outcomes, but that even within a single clutch of eggs where those are all siblings, all sisters, you may have actually different types of salamanders being produced.
It's amazing that they have this scenario of having multiple genomes, but I think what puts it into perspective is how distantly related these species are that are sharing this genetic information. If we were to take a sample of my blood and I had a set of chromosomes from my mother, from my father, but in addition, a whole set from a gorilla, from an orangutan, from a chimpanzee. That's the type of evolutionary divergence between these salamanders, but I would be a fully functioning, normal human being.
We have a salamander in here.
No.
Yes.
What?
Yes.
Oh, buddy. What we're setting up here are breeding experiments where we put the unisexual females in with different types of males, and then we genotype the parents and the offspring to see when the male DNA makes it in. So far what we've been looking at is whether the female has any preference for a male that's from her same pond versus a male that's from a more distant pond. And over the last couple of years, we've been running these experiments and are so far seeing a pattern where the females are more likely to include the male's DNA if he's from the same pond that she is versus a pond on the other side of the reserve. You could imagine that if you are a unisexual with a lot of blue spotted DNA and you end up in a pond with a lot of Jefferson salamanders, that's probably a good place to be a Jefferson salamander. And so as that female, are you more likely then to add some of those Jefferson's genes to your offspring, in which case you're able to potentially grab a whole locally adapted genome and stick it right into your offspring without splitting it in half.
So I'm working to establish a collection of these animals that captures their whole diversity across their range, from Kentucky to Maine to Minnesota to Canada. Some of these people who work for state agencies or wildlife management areas sample these animals every year, help them cross the road, protect them, educate the public about these animals without ever really knowing what they have. How many genomes does it have and where do they come from? And so this is a way that we can answer some of those questions and also ask more basic research questions about their evolution, for instance. This scenario of having these multiple genomes produces some really confusing results. So for example, we have studies that show that they can regenerate their tissues faster than sexual species. At the same time, there are other tests, such as locomotor endurance, where they perform really poorly. They're very successful. Across their range, they're often abundant. Sometimes they can outnumber the sexual species by 2 to 1, 3 to 1 at these wetlands. So we know they're doing well. We know they've been around for a really long time, but it's really difficult to explain why that is.
These salamanders really are taking advantage of the system, right? They're all female, so they don't bear that cost of producing males, but they're occasionally incorporating DNA from other species. In some ways, it seems like this potentially totally unique evolutionary win-win, which might ultimately let us learn a little bit more about the evolution and maintenance of sexual reproduction.
They defy all boundaries of what we know a species is. So it raises a lot of interesting questions about what do we care to conserve? An individual that we know is a blue-spotted salamander or their genetic legacy. People argue about what a species is, and these animals are so far from that argument that it's not even worth having it.